Now I present theory about reference dependence. Already told you we don't have much theory, it will be mostly just notation, but here it comes. A reference point in general is denoted by theta, but in this course we will use the scale theta equals 0. That means outcomes then describe changes with respect to the reference point. And then improvement, positive outcomes, we call them gains, negative outcomes we call losses. There will be utility function as usual, although the mathematically oriented listeners will already notice this is now small u rather than capital U. Well, more on that later. I call it the basic utility function. We're scaling util to 0 at the reference point. We've seen before all kind of cases where scaling was free to choose. You could add any constant to utility that you like, it doesn't matter. Here, well, this will be part of prospect theory. I will define it later, but then it will come out that you have to scale utility to be 0 at 0. You can't add any constant or subtract any constant. If you do anything different than this, the formulas are simply not correct. So now it is crucial. There's no liberty of scaling here. We have a positive lambda, the loss aversion factor as I call it. Then we have another concept of utility, denoted capital U now. That is called the overall utility. And let me explain how it is related to basic utility. Well, for gains, the two are just the same. But for losses, the overall utility is lambda times basic utility. So that means this loss aversion factor, it controls the exchange rate between gain and loss utilities. We say loss aversion is lambda if lambda is greater or equal than 1. Now, loss aversion does not mean that people dislike losses, because it's trivial. Everybody dislikes losses. We don't need a term for that. Loss aversion means something different. It is not an absolute concept. It is a relative concept. It compares losses with gains. Loss aversion says if you face a particular loss, then you are suffering more than you would be getting happiness from an equally big gain. It's a sort of overweighting of the losses relative to the gains. It's a relative concept. So I could depict it in this manner. For losses, it goes down steeper than for gains, it goes up. That is loss aversion. The opposite we can call gain seeking. And again, gain seeking does not mean that people like gains, because that's trivial. We don't need a term for that. Gain seeking means that people are relatively overweighting gains towards losses. And again, relative concept. This also means that these concepts only play a role when both gains and losses are involved. And we call it mixed gambles if gambles are yielding both gains and losses. If, for instance, we are in a domain with only losses, then the loss aversion parameter doesn't matter. It doesn't impact anything. It has no meaning in a way. Now, here is a figure from the book that depicts what I just told you. I have in mind that basic utility is a rational component of utility. It captures a real value of the outcomes. And it's well behaved, it's smooth, and really at 0 it is differentiable. There's no reason why just above 0 or just below 0 the marginal utility would be different. So this is what basic utility is. Now, overall utility brings in that loss aversion parameter. So then that can be bigger than 1. Then for the losses, the whole curve is pulled down by that positive factor. That means at 0 we have a non-differentiable point, we have a kink. Suddenly, if you come below 0, then the marginal utility is much bigger than it was above 0. Now, I have in mind that loss aversion is not about true value of outcomes. It's a sort of irrational psychological component. People have this, the moment they could lose, people have a special fear of losses. The moment that they may lose, they say, oh no, I don't want it. I don't want to risk any loss. That kind of psychology is happening a lot. And I think empirically, maybe more than 50% of the risk aversion that we observe is in fact due to loss aversion. That people have this, the moment there may be a loss, they get scared, oh, I don't want it. And this is a framing effect. It depends on how you frame. If you can rephrase things such that people psychologically perceive the reference point to be different, then their behavior changes, although rationally speaking, it should not. That's that part of reference dependence, and that is how I interpret loss aversion, how it will be defined. If something is real, true value of outcomes, then it's in the basic utility function. So if, for instance, you are at the level of income such that any €1 or $1 less you get, you really suffer more than that you gain from getting one extra dollar or €1, then it should not be loss aversion, but it should be part of the basic utility function. Then it should have a kink at 0, because then that is real utility. But it's very, very coincidental if this would be exactly at the reference point. So, but anyway, that's the interpretation that I use in this course. Now, this will be part of the definition of prospect theory, but that will be presented to you a bit later. First thing to come after this is the famous Rabin paradox. That shows you, if you are not aware of reference dependence, if you do not incorporate in your model, things can go horribly wrong. So even although it is so hard to model, we have almost no theory about it, we have to do it, because otherwise we really don't understand what human beings are doing. And that will be in the next recording.